let's solve this second question here under progressive wave. It said if a wave is represented by the expression y equal to a sine into 1000 pi t minus 10 pi s over 24, all in cm, we are going to know what to do here. Where t is in seconds and y is the displacement, find a wavelength, b velocity, c frequency, d amplitude. Okay, now first of all, before you find or calculate this stuff here, you must first of all find all the wave parameters from this progressive wave equation. Please take note. So what are you going to do? As far as whenever you see any expression like this as progressive wave equation, the first thing you have to do first is to compare the standard equation with the given equation. So the standard equation here I'm going to use will be y, since it's said to be sine, to be y a sine into omega t minus, why am I using minus? Because there's minus here from the equation, minus what? 5. Please take note. Y, the given one is said to be y is equal to a sine, please take note, into 1000 pi t minus 10 pi s over what? 24. Please take note, okay? In what? Cm, okay? In cm, okay? Let me explain this. Whenever we are giving a unit like this, that is this cm like this outside, listen to me please, listen to me. Whenever we are giving cm like this outside, it means that this cm here is only affecting the parameters outside, not inside the brackets. Now, what are the parameters outside here? It's said to be amplitude and what? Displacement. So this cm here is not affecting the parameters inside, it's only affecting the parameters what? Outside. Please take note. So that means this cm here is only affecting amplitude and what? Displacement. Please take note. So any other thing inside this bracket here should be what? This class should be what? Under what? SI unit, except it's being stated in the equation. They said where t is in seconds already, y is what? The displacement. Okay, now let's solve this question here. Of course, we know what the unit of a will be, which I told you guys. We know what y will be, but this one here that's not being stated in the equation here should be all in what? SI units. Okay, now let's compare here to find the parameters. This is amplitude, this is amplitude. This is displacement, this is displacement. Okay, now this is amplitude, this is amplitude. That means our amplitude A is said to be ACM. Okay, please take note. You can also convert this one in what? In meter by dividing with what? 1000. Okay, now the next one here is, I can't compare this to this because there's nothing like wave parameter in terms of sine. In terms of wave parameters, we do not list sine as part of wave parameters. So I can't compare this to this. Let's go here. This to this will be omega t will be equal to class 1000 pi t. Please take note. Now if you look into this here, there's something common here, also common here. What is that? T. Divide both sides by t. I'm going to have omega will be equal to 1000 pi of what? Rad per what? Second. This rad per second is the unit of what? Omega. Okay, compare this guy with this guy here. This minus will cancel this minus. Means that phi is said to be 10 pi x over what? 24. Please take note. So class, this is what you should do first before you calculate what you are asked to calculate here. This is what you should do first before you calculate what you are asked to calculate here. Please take note of this. So now let's solve the question here. They said A, wavelength. Which particular formula that relates with wavelength here is this class? Angular, phase angle. That is our phase angle here is said to be this. So let's solve this here. That is A. A is wavelength. Now amplitude is not related to wavelength here in terms of wave equation or parameters. Angular frequency is only related to what? Frequency in terms of wave. Now this, which is said to be phase angle, is related to wave, because say that phase angle phi is said to be 2 pi s over what? Lambda. Please take note of this. So class, let's try to solve this. Now solving this here, anywhere I see phase angle is already given to us here. The value is this guy here. Now I replace this guy. Anywhere I see this is going to be 10 pi s over what? 24. So this is going to be 10 pi s over what? 24 is equal to 2 pi s over what? Lambda, sorry. Now our intention here is to find lambda. But listen, in mathematics, whenever you see division at the left, division at the right, the next thing you have to do is to cross multiply. When you do that, this is going to be 10 pi s times lambda is equal to 24 times 2 pi s. So let's find lambda. I'll divide both sides by what is attached to this lambda here. That means our lambda here is said to be 24 times 2 pi s over 10 pi s. So this guy, we cancel this guy here. So let's solve. Our lambda here will be equal to class. This time, this will give us 48. 48, this thing, 48 divided by 10 is going to give us 8.4. Sorry, 48, that means 48, that means 4.8 in what? Meters, okay? Okay. Now the next one here, that is B here, is to calculate velocity. And class, what is our velocity here? Please look up here, please. Velocity is said to be V is equal to, that is for wave, F lambda, okay? Now our intention here is to get this, that is frequency and what? Wavelength. Wavelength is already given to us here as what? 4.8. Now the next thing here is to get our frequency here. How can we get frequency from any of the parameters given to us here? From where? Angular frequency. And angular frequency here is said to be class omega is equal to 2 pi f. Please take note. So let's replace here. Omega is 1000 pi is equal to 2 pi f. Now make f the subject. F will be equal to class divide both sides by what's attached to f. That is 1000 pi over what? 2 pi. So this can cancel this. This can cancel this. I'll be left with this will give us the 500 Hz. Please take note. I'm going to have 500 Hz. So anywhere I see frequency, I'm going to put down this value here. That's what? 500 Hz. This will be V will be equal to 500 times 4.8. So punch your calculator, please. 500 times 4.8. What is the answer, please? Yes. Okay, 500. Let's go here. That is V is equal to 500 times 4.8. That is 2,400 in what? Meter per second. Class, we have calculated this guy here. That is wavelength. We have calculated this guy here. That is velocity. And also from calculating velocity here, we have to get frequency. That means we have calculated this guy here. That is frequency. The next is amplitude. If you look into here, we have calculated amplitude from comparison between the standard progressive wave equation with what? The given progressive wave equation. So the amplitude here is said to be ACM. The amplitude is said to be ACM, and we can't actually calculate in CM. What am I going to do here? I'll divide everything here by what? 100. This will give us in meter to be what? This class 0.01 watt meters. Please think of this. Okay, you can write.